Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers trigonometry. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 8 wants us to circle the exact value of cos 30. Now for your exam you're going to need to know the exact values for the sine, cosine and tangent for 0, 30, 45, 60 and 90. You've got two strategies really. You can either try and memorize the whole table or you can learn how to derive them for yourself. I think the second method is better. I'm going to quickly show you how to derive cos 30 from an equilateral triangle. So the first thing we do is going to draw an equilateral triangle. This is an equilateral triangle of side 2. Now I'm going to divide this triangle into two equal right angle triangles. So these two are the same length. So the whole length is 2, so this part of it has to be 1. Now it's an equilateral triangle, so all the angles were 60. So because I cut this one in half up here, that one's going to have to be 30. And finally, I need to know the length of this side here. Using Pythagoras theorem, I know that this side of a right angle triangle must be, I can use it's the hypotenuse squared minus the shorter side squared, all square rooted. So that is equal to 2 squared, which is 4, take away 1 squared. So basically it's root 3. Okay. So using our knowledge of trigonometry, I want to know the cosine of this 30-degree angle here. Now the cosine of an angle is equal to the adjacent over the hypotenuse. So from the 30-degree angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So we need to know cos 30, which is the adjacent, which was our side here we worked out using Pythagoras theorem, divided by the hypotenuse, which was 2. So the one we want is that one there. Right, for which acute angle does sine x and cos x have the same value? Now you need to know all of your sine and cosine common ratios from 0, 30, 45, 60, 90 for all of sine, cosine and tangent. And if you've done that, you'd remember that those two have the same value for 45 degrees. Question 14. Which of these values cannot be the cosine of an angle? Circle your answer. Okay. Well, all sines and cosines must be between -1 and 1. So anything above 1 or less than -1 cannot be the cosine or a sine of an angle. So minus 0.5 is fine, 0 is fine, 0.5 is fine, but 1.5 is outside the range of possible solutions. Okay, which expression gives us the area in centimeters squared of this triangle? Well, the area formula for a non-right angled triangle uses trigonometry, and it's half AB sine C, isn't it? That's the formula we know. In this particular triangle, this is your A, this is your B, and this is our C. So we're going to get a half times 8 times 10 times sine x. Half 8 times 10 is 40, so it's 40 sine x. That one there. Okay, question 21. We've got a diagram of a triangle on top of a rectangle. We know that the two areas of the triangle and the rectangle are equal, and we're told that BC is 2 centimeters shorter than BE. However, we haven't been given what BE is, so let's call it x for now, which means that BC is going to be 2 shorter. It's going to be x minus 2. Okay, so I know that my area of my triangle is going to be equal to my area of my rectangle. Now, I've been given an angle in the triangle, so I could work out the area of the triangle using trigonometry. I've got a trigonometry formula I can use, which says the area of a triangle is a half AB sine C. An area of my triangle is going to be length times width. So in terms of this diagram, it's going to be a half. A is 10. B is x, don't know what it is yet. And then I've got sine 30. And my length times width of my rectangle is going to be x minus 2. Okay, I think this is looking promising. So sine 30, you should know, is equal to a half, because you should know your exact values for common sine ratios. So sine 30 is a half. Half of 10 is 5x. So 5x times a half is equal to x squared minus 2x. So 5x times a half is 5x over 2. So it looks like we're going to have a quadratic in x that we need to solve. Let's put everything on one side. So x squared minus 2x. If I took this onto this side, it would be negative, wouldn't it? So minus 5x over 2 is equal to 0. So 5x over 2, take away another 2, is x squared minus 9x over 2 equals 0. Factorising out an x. So either x is equal to 0, which is not very helpful, or x equals 9 over 2. Or, if you don't like fractions, that's 4.5. Question 19. In this question, all lengths are in centimetres, and we're told that the triangle and the trapezium are equal in area. Work out an expression for y in terms of x, given that the sine of theta is equal to 1/3, and give your answer in the form y equals a over bx, where a and b are integers. Okay, so we've been given a triangle. We know two sides algebraically, and we've been given the angle and the sine of that angle. So we're going to use the sine formula for the area of the triangle. So area of our triangle, well, the formula is half AB sine C. Okay, but in terms of this particular triangle, that's going to be half of our two sides. That's 6x and 8y times the sine of theta. And we're told that sine of theta is 1/3. So that is, well, I've got half times 6 times 8. So half of 8 is 4. 4 6s are 24. So 24xy. And the sine of theta we said was 1/3. So 1/3 of that. 3's into 24 go 8 times. So that is 8xy. Okay, next let's have a quick look at the trapezium. Now the area of a trapezium is equal to a half a plus b h, where a and B are your two parallel sides, and h is the distance between them. So a is 10x, b is 4x, and h is 3x. So that's going to be half of 10x plus 4x times 3x. Is that right? Yeah. So 10x plus 4x is 14x, divided by 2 is 7x, and times by 3x is 21x squared. Okay. So now we're told that these two areas are equal to each other. So area of my triangle is equal to the area of my parallelogram, which means that AXY must be equal to 21x squared. Now what are we looking for? We're looking for y in terms of x, so we need to make y the subject here. So cross multiplying the AX part over here, then we get y equals 21x squared over 8x. So cancelling that x with that x squared, and can I cancel down top and bottom? Nope. 8 and 21 don't have any common factors, so I'm just going to leave it like that. So y equals 21x over 8. Question 17. Here is a triangle. It's not drawn accurately, and we're asked to circle the correct equation. So these are all kind of formulations of the sine rule, aren't they? So what does the sine rule say? The sine rule says sine A over A equals sine B over B is equal to sine C over C, or the other way up, that A over sine A equals B over sine B, which equals C over sine C. Now we are wanting to find x here, aren't we? So we want the bits with x at the top. Now x is a side, so we're going to write it down with x is on the top, or the lengths on the top, and the angles on the bottom. Now side x is opposite angle 42. Angle 34 doesn't have a side opposite it, so that one is no good. 15 is opposite 104. Okay, now the sine rule is all about these opposite pairs, so you need to have two pairs of opposites, an opposite side and an angle. Okay, so I can see that x is opposite the angle 42, and I can see that the 15 is opposite the angle 104. So I'm going to write it down using the sides on the top, so like a over sine A equals b over sine B, that way around. Okay, and then so let's sub in for x. So putting my x on the top over the sine of the angle opposite to x, which is sine 42, and that is going to be equal to, and then writing down my other pair, my 15 over sine 104. Okay, so opposite pairs, that one goes with that one, and that one goes with that one. And my x over sine 42 is that pair, and my 15 over sine 104 is over that one. That one didn't come out very well for some reason. So which one is that? Oh look, it's that one there. Okay, question 13a. We earn our second mark of the paper for knowing our exact trig values. The value of cos 60, of course, is a half. And then 13b, we're going to go on to use that, I think. So I've got a triangle here. It's a non-right angle triangle. So we're going to be using the cosine rule here, because I've got two sides and an included angle, and I want a third side. So let's label up the triangle. So this is my side B, so that there at the top must be angle B. So let's just call the other two sides, our other two letters, that must be A and that must be C. So then writing down the cosine rule in terms of B, I've got B squared equals A squared plus C squared minus 2AC cos B. Now I don't know which way you've remembered it, but you should be able to reformulate it for any given side. You just have to swap these a's, b's and c's around in there and follow the pattern. So b squared equals a squared plus c squared minus 2ac cos b. We can now sub into that all the values that we know. So a is 5, so 5 squared. C is 8, so 8 squared minus 2 lots of 5 lots of 8 times cos b, cos 60. So 5 squared is 25, 8 squared is 64, subtract 2 times 5 times 8, 2 5s are 10 times 8 is 80, and cos 60 we said earlier was a half. So 25 and 64 make 89, subtract 40, which is 49, isn't it? And the square root of 49 is 7 as required. Question 29, horrible one to finish with. Simplify 2 sine 45 degrees minus tan 45 degrees divided by 4 tan 60 degrees. Give your answer in the form root a minus root b over c, where a, b and c are integers. So basically we need to recall our exact values for trig and do some surd simplifying to finish off with. So first thing is, do you remember your exact values for trig? Well, which ones do you need to know about? You need to know about values of theta for 0, for 30, for 45, for 60 and for 90 degrees for your 3 types of trig ratio. So sine theta, cos theta, tan theta. Now, the first and last are easy. The sine of 0 is 0, the sine of 90 is 1. Most people don't have too much trouble remembering that the sine of 30 is a half. So that leaves us the sine of 45 and 60 that we need to remember in surd form. 45 is root 2 over 2, and 60 is root 3 over 2. Now cosine's easy. Once you've written those down, the cosines are the same as the sines but backwards. So rather than having 0 half root 2 over 2 root 3 over 2 1, it's the other way around. So it's 1 root 3 over 2 root 2 over 2 a half 0. And the tan is the first one divided by the second one. This is the sine theta divided by cos theta. So 0 divided by 1 is 0. Half divided by root 3 over 2 is 1 over root 3. 2 root 2 over 2 root 2 is 1. Root 3 over 2 divided by a half is root 3. And 1 divided by 0 is infinity. Okay, so they're all the values that we need to know. Now how you remember those is another video, but you need to remember all of them if you don't remember it the way I just did. Okay, so now we know what they all are. Let's sub them into this formula and find out what we've got. So 2 sine 45, that's equal then to 2 sine 45 is root 2 over 2 plus, sorry, minus tan 45. Tan 45 was 1 minus 1 divided by 4 tan 60. So divided by 4 tan 60, which is 4 root 3. Okay, so you notice here our denominator has to be a whole number, and at the moment we've got a surd down there. So we can simplify this a little bit. Well, let's multiply out the top part first. So they cancel, don't they? So it leaves me with root 2 minus 1 over 4 root 3. So to simplify the denominator, if we times top and bottom by root 3, root 3 divided by root 3 is 1. So multiplying through by 1 doesn't change it, but it will just change the form somewhat. Root 3 times root 3 is a 3. So on the bottom, that changes to 4 times root 3 times root 3, which is 4 times 3, which is 12. On the top, I'm going to get root 2 times root 3, which is root 6 minus minus 1 times root 3 is minus root 3. So I'm going to get minus root 6 minus root 3 all over 12. So I think that is in the form that they want it to be. Yeah, got root 6 minus root 3 all over 12. So that actually wasn't as bad as I thought it was going to be. The key to it really is remembering this here. If you don't know these, you're a bit scuppered on these sorts of questions. So you need to find a way of remembering your exact trig values. Okay, I think we're done. Question 30, show that the exact value of cos 30 times tan 60 plus sine 30 is an integer. Okay, now again, these involve the exact trig values that you need to remember. I did mention earlier you need to remember the sines, cosines and tangents of the angles 0, 30, 45, 60 and 90. Okay, so I'll just pull it up on in a little table here for you to have a look at. So we can see from the table that the cosine of 30 is root 3 over 2. I'm multiplying that through by the tan of 60, which is root 3 plus the sine of 30, which again from the table is a half. Okay, so now unless you remember all those values, you are going to have no chance at all with this question. So you must memorize this table. It's not quite as hard as it first looks, because you'll notice that the sines and the cosines is the same list written backwards, and actually tan is the sine divided by the cosine if you ever get stuck with that one. So really you just need to remember one of the lists and you can generate the other two. But whichever way you do it, you need to be able to remember what these are. Okay, so now I've got them written down, I've got an outside chance to be able to answer the question. So I need to show that it's an integer. Okay, so, well, that's not very hard. Root 3 times root 3 is 3, isn't it? So that's 3 over 2 plus a half. And what's 3 over 2 plus a half? That's 4 over 2, which is the same thing as 2. So it was super easy once I remembered or knew what those values were to start with. Okay, job done, paper done. So if you need some more practice on an individual topic like trigonometry, then why not check out my series of videos on topic tests. There's one on trigonometry, there's one on the sine rule, cosine rule, and there's a lot more from you to discover as well. I'll put a link to the playlist above. So if you click on that link, it will take you through to the topic tests where you can study individual topics in more detail. It's a good way to alternate actually. So if you do a practice paper, you'll be identifying several topics where you still need to do a bit more practice. Then you can pop over to the topic tests, hammer a few more questions on those before you come back and do the next past paper. I'll be uploading the other past papers for June 2018 very soon. So if they're not already up there, they'll be up soon. So why not subscribe? And then you'll get a notification when it pops up. Question 26. The area of this triangle is 25 root 3 centimeters squared. Work out the value of W. Give your answer in the form of A root B, where A and B are integers greater than 1. Okay. So the area of this triangle is 25 root 3. So we know that the middle of this is 25 root 3 centimeters squared. Okay. Now, we're going to be using trigonometry here, and we're going to be using it twice. Firstly, so I can find my value of x, and then once I've found x, I can go on to find the value of w using the cosine rule. But we're going to find the value of x first, using the equation for the area of a triangle that is trigonometric. So what is the trigonometric area of a triangle? We know that the area of a triangle is equal to half AB sine C, where A and B are the two sides and C is the included angle. So here we know what the area is. We know it's 25 root 3. So let's sub in everything we know. That's half. A is 20. B is my x value that I'm trying to find. And sine C is the sine of 60 degrees. Okay. So what do we know from here? Let's just try and multiply it out and simplify it down. So 25 root 3 is equal to, what have we got on the top? We've got 20 times x times the sine of 60 divided by 2. Okay, let's just get rid of the divided by 2 first. Let's make that 10. So I've got 10x times the sine of 60. So that's 10x. What is the sine of 60? Now, that's again, it's one of our exact values that we talked about earlier when we were looking at one of the earlier questions. And if you remember that table of values that I pulled up earlier, you should remember that you need to know that the sine of 60 is root 3 over 2. Okay, so we're getting there, aren't we? So now what can I do? I've got root 3 on both sides. I've got a root 3 and I can cancel it with that root 3 there. That should make life a lot easier. I can divide the 2 into the 10 and make 5. So now I've got 25 is equal to, well, it's equal to 5x. And then divide both sides by 5. I'm going to get x is equal to 5. Okay, so that's promising. So now coming back to my diagram, I know that that x is equal to 5. So now I've got two sides and an included angle, and I want to find the third side. This looks like a job for the cosine rule. Okay, so the cosine rule. Using cosine rule, what's the cosine rule say? It says c squared is equal to a squared plus b squared minus 2ab cos c. Okay, so it's a bit like the Pythagoras theorem with that extra little bit on the end. So here, c is my w, isn't it? So w squared is my two sides that I know, which I now know are 5 and 20. So it's going to be 20 squared plus 5 squared minus 2 lots of 20 lots of 5 times the cos of the angle, which is 60. Okay, so let's see that through. 20 squared is 400. 5 squared is 25. Minus 2 times 20 times 5. 2 5s are 10. 10 20 is 200. So that's 200 lots of cos of 60. Now again, from our table, we should know that the cos of 60 is a nice easy one. It's a half. So a half of 200 then is 100, isn't it? So I've got 400 plus 25, 425. Take away 100. That gives me 325. So my w then is going to be the root of 325. Is that what they wanted? Give your answer in the form a root b, where a and b are integers. Okay, so basically now we've got 325, and what we need to do then is simplify that surd down. So we're going to be looking for factors of 325 that are also square numbers. I think 25 is screaming at me at the moment. How many 25s in 325? Well, there are 4 25s in 100, so 300 has got 12, plus another 25 is 13, isn't it? So that is 25 times 13, and the square root of 25 is 5, so that's just 5 root 13. So w is 5 root 13. That's a fun question. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.